Imagine an environment so hostile that to survive, you need to carry your entire world with you in a bubble. The vacuum of space, the crushing depths of the ocean, the toxic atmosphere of another planet. Our current suits are incredible life support boxes, but they are heavy, bulky, and utterly dependent on supplies from home. What if the suit itself was alive? What if it could breathe, recycle, and even heal, just like a second skin? Welcome to Boson Buzz. I'm Monty Molecule, and today we're reimagining the frontier outfit. We're meeting the living, breathing partners for extreme exploration, the Symbiotic Suits. Our story follows a crew preparing for the first long-term mission to the Martian surface. The challenge isn't just getting there, it's living there. Every breath of oxygen, every drop of water, every bite of food must be shipped from Earth at astronomical cost. A spacesuit for a surface walk is a personal spaceship, but it's a leaky one. Carbon dioxide builds up, sweat soaks the interior, and the oxygen tank always has a limited supply. It's a countdown clock strapped to your back. But in a lab that looks more like a futuristic garden crossed with a textile factory, biologists and engineers are weaving a new solution. They aren't just building a suit, they are growing an ecosystem. The Symbiotic Suit is a lightweight, flexible garment lined with a living layer of specially engineered microbes and plant cells. These aren't germs that make you sick. They are helpful, tiny partners with a job to do. Think of the suit as a wearable forest. The first and most crucial layer is made of photosynthetic cells, derived from algae or hardy plants. Woven into the fabric of the suit's outer layer, these cells soak up sunlight, or even the light from your helmet lamp, and the carbon dioxide you exhale. Just like leaves on a tree, they use this to produce fresh oxygen. Suddenly, your suit isn't just storing air, it's making it, constantly replenishing your supply from your own waste breath. The second layer deals with water. In a current suit, sweat and moisture build up, making the astronaut cold and uncomfortable. The Symbiotic Suit has a microbiome layer designed to manage humidity. Helpful bacteria absorb that moisture directly from the air inside the suit. But they don't just store it, they purify it. They break down salts and other compounds, releasing clean, drinkable water into a small reservoir in the suit's collar. When you're thirsty, you take a sip. Your suit literally drinks your sweat and gives it back to you as fresh water. The suit is also self-maintaining. Another strain of engineered microbes is embedded in the material itself. If the suit gets a small tear or puncture, a major danger in space or deep sea, these cells sense the change in pressure or chemistry. They swarm to the site and secrete strong, flexible biopolymers, a natural living glue, to seal the breach automatically. It's like having a team of microscopic repair crews woven into your clothes. Now let's suit up our Martian explorer. Instead of climbing into a rigid, bulky suit, they slip into something that feels more like a high-tech wetsuit. It's form-fitting and allows for much more natural movement. As they step onto the red dust, sunlight hits the suit's outer layer. The photosynthetic cells activate, starting the oxygen cycle. With every exhale, the suit's inner lining captures CO2. The explorer can work for hours, knowing their air is being refreshed with every breath they take. They take a sip of water from the tube at their shoulder, water that was in their own body just hours before, now cleaned and recycled. The difference is night and day. Gone is the constant, heavy whir of air pumps and the stiff resistance of joint bearings. Instead, there's a quiet, biological hum, the feeling of being inside something alive and responsive. After a long day of collecting samples, the explorer feels a wave of fatigue. The suit's inner layer, laced with biosensors, detects the stress hormones and elevated heart rate. In response, it gently releases a soothing, naturally produced compound through its inner lining, like the calming scent of a forest after rain. At the same time, the material around their lower back and shoulders stiffens ever so slightly, providing dynamic support exactly where it's needed. The suit isn't just a tool, it's a companion that understands the strain of the mission and actively works to keep its wearer healthy and focused. The applications are vast. For deep-sea divers, a symbiotic suit could manage different gases at extreme pressures and use bioluminescent microbes for communication or to attract curious sea life for study. For firefighters entering toxic, smoky environments, the suit could actively filter out poisonous chemicals and produce oxygen from the surrounding air, even in a void. Looking to the future, this technology could enable truly long-term living in space. On a journey to Jupiter's moons or in a lunar base, symbiotic suit technology could be scaled up to line the walls of habitats. The entire living quarters could become a giant breathing organism, regulating air and water for the crew indefinitely, turning a sterile metal can into a living, life-sustaining home. But perhaps the most profound evolution is communication. Scientists are working on integrating neural interfaces with the suit's living layer. The suit could monitor the wearer's vital signs, stress levels, and even muscle fatigue through biological sensors. It could then respond, not with a beeping alarm, but by subtly releasing calming compounds to reduce stress or tightening certain areas to support tired muscles. The suit wouldn't just protect the body, it would partner with the mind. This changes the very philosophy of exploration. We are no longer just visitors in harsh environments, wrapped in a fragile shell from home. We become integrated with a living system that helps us adapt, turning our life support into a sustainable, self-renewing partnership. It redefines the relationship between explorer and environment. The symbiotic suit isn't a barrier against the world. It's a bridge, using life's own genius to help us survive where life supposedly can't. It promises a future where our exploration gear is alive, where deep space and deep sea feel a little more like home, because we bring a piece of home's resilience with us. If this vision of living technology sparks your imagination, please like and subscribe to Boson Buzz. Until next time, have a safe and curious week.